Right, let me, this chapter is minus, sorry. This is plus, so let's do that for this example here then. You write down the constant 3y cubed times differentiate x with respect to x is 1. Okay, so the answer to that is 2. This is plus, just go to see on the bottom here. Let me rewrite this one. You've got 4 times y times x cubed. This is plus. 4 is a constant, you differentiate with respect to x. You're treating all other variables as constant. 4y is a constant. This is an example of a constant times x cubed. How do we differentiate a constant times x cubed? You write down the constant times differentiate x cubed, which is 3x squared. Y is a constant. What about sine y? That's a constant as well, isn't it? Sine 1 radian, that's a number. All that is a constant. Minus, sorry. There. So this is an example of a constant times x. How do you differentiate a constant times x? You write down that constant, which is 2 sine y times differentiate x, which is 1. That's a constant as well, isn't it? And therefore, this here, so this is 2 sine y. That's a constant as well, isn't it? Y is a constant. What's the log y? This is log of that function of x, log of that function of x, log of that function of x. That's a constant as well, isn't it? Differentiate 3 log y with respect to x. You're going to treat y as a constant. What's the differentiation of 3 times log 2? So that's the numerator then. That's taking care of the numerator there. What about the denominator? You're now going to work out this term. That's a constant as well, isn't it? So you treat all x's in that expression as constant. See, 3 is a constant, x is a constant. You write down the constant. Multiply by differentiate y cubed with respect to x is 3y squared. You differentiate y with respect to x now. Okay, so differentiate y with respect to x, that's the standard derivative there. Y is a constant. What's log y? 4x cubed is a constant. You're now treating x as a constant here because you differentiate past respect to y. Okay? That's a constant as well, isn't it? Differentiate past respect to y, you treat all other variables as constants. So differentiate with respect to y, treat x as a constant. Minus differentiate 3 log y with respect to y, well that's your normal one. I mean, you notice I didn't need to use the product rule there. Y is a constant. What's log y? Treat x as a constant. What's log y? Differentiate with respect to y, 2x is a constant. Differentiate with respect to y, and that's exactly what it says there. That's exactly what we've got at the top there. I mean, that's a constant as well, isn't it? I mean, you notice I didn't need to use the product rule there. Okay, well that's implicit differentiation then. However, there is a quicker way. We don't need to go through that because this is an example. If you remember, I have sort of mentioned this. Right, let me, there are other, this chapter is, right, logs, for example. If you would log of a product or term, see the first thing that you will notice there is that log, this is the first thing you would start off with differentiating this without using log properties is to tell yourself that. Look at that function of x in there, you put it in there, you put it in there. Just tell yourself that. So, I mean, I'm not going to go through all this. So you still got this bit left to work out. d by dx of all that, well, times sine x times d by dx of all that term inside there. You tell yourself that. Right, I also mentioned this a couple of times now. It's quite easy to see that whenever you got sort of log or, you know, a, b, c over e, and that, you can skip that out as log a plus log b plus log c minus log e minus log f. That's easy to complement. Tell yourself that. So we've now split them up into 3 separate log terms there. Okay, and we no longer got any products involved. It's log of that function of x, log of that function of x, log of that function of x. So if I do that for all 3 terms, it's quite easy to see that you get these 3 terms there. But nevertheless, at least we've got a formula for it. A, you've still got these bits to work out, of course. Those are the things that are still outstanding. It will take you a while to do that. Having said that, this one is pretty straightforward. That is 4, and this is your sort of final result. So that's, but there is one further step, is this one. It's quite easy to see that you get these 3 terms there. Having said that, what about log of this function? What about log of that function there? I mean, if I ask you what's the slope when x equals 1, You can split it up, you see. What about log of this function? What about log of that function there? But again, you can split it up, you see. What about log of this function? What about log of that function there? How do you differentiate that? Let me spell it out here. 1 upon e to the power 2x times d by dx, or e to the power 2x. But there is one further step. And then finally, sort of, take the 4 out, you got that. Take the 2 out, power 2 altogether. Okay, so the answer to that is 2. And this is very similar to the previous example. And again, that's the answer. And this is your sort of final result. Now, this one is log of a c divided by b is log a plus log b plus log c minus log b there. A times b, a times b, a times b times c divided by b. A times b times c divided by b. But again, you can split it up, you see. A times b times c divided by b. So this is the example of a function of a function of a function, yeah? So we can simplify that. That's 3. I quite often find you would have made life a lot easier had you taken the 3 outside. If you didn't take the 3 outside, what that is by function its number, and you end up around result there. That's an example of a function of x all squared. But let me remind you, had you done it this way, you see, you take that cube out there. And let me go back to this. How do you differentiate that with respect to x? It's 1 upon all that. Let me, how do you differentiate that? This one will cancel with that 2. But that appears on your function formula sheet as well. That is 2 times 2x minus 1 to the power 1 times d by dx of 2x. Sorry, I missed my, what did I have there? That's a constant as well, isn't it? There was a 3 in front of all this, by the way. This is what we differentiated, yeah. Okay, right on. Now, differentiate this back to y. Treat x as a constant. That's a constant as well, isn't it? Logs, for example, what's the log of the inverse log of 2x? Well, the answer is obviously 2x, of course. Differentiation of all that is 2 e to the power 2x. You've got 2x, which is 2 there. So take the 4 out, you've got that. Take the 2 out, power 2 altogether. Okay, so the answer to that is 2. It'll take you a while to do that if you didn't use log properties to differentiate that. Then finally, see, what's log y?